Welcome to Trust, Visible and Invisible, What We Owe Each Other in Open Source. Throughout this talk, I'll be making some references to publications, articles, journals, blogs, books, and the works of others. I've collected a list of those references in a README in this GitHub repo. So if you're interested, whether you want to follow along or just reference it later, there's a sort of a bibliography up there for you. And I'm going to start in this talk with a bit of a little story from my own college years. I was studying the Buddha Dharma and sort of the evolution of Buddhism in university for a few years, sort of a break between tech. One day, my professor walks into class, Professor Alan Grippard at UCSB, and he holds up his car keys and he just asks everyone, "What is this?" And someone, of course, says, "Oh, those are your car keys." And he looks at them like, "Yeah, duh," and says, what is this? Someone else says, "Well, it's a bunch of metal in a very particular shape that has a purpose." And he says, "Okay, so for this to be what it is, what else must be? What other concepts do you have to understand to know what this is?" And the class starts to throw out answers. Someone says, "Well, you have to have a car. And you have to know what a car is. And that implies that there's a road, and that a crew of people built that road. That implies you have somewhere to go. There's other cities. It implies that there's a combustion engine and scientists who invented that, and some sort of a fuel source like oil to power that combustion engine, a mine to mine the metal, an economy to transport all those things, possibly even borders. And differences between, the shape of a car key here and a key for a car made in a different country." And so just from car keys, he taught the concept of codependent origination, the principle that everything we know and every thought that we have about those things is interdependent on other things to contextualize its existence. The particular shape and place, time, usefulness of something depends on virtually everything else, today and before us in history. If you change one piece, that ripples through everything else. We're here today, though, to talk about open source software which relies on computers. So let's ask the same question for a moment. For this old Ubuntu laptop to be what it is, what else must be? Besides the obvious, someone had to write the operating system. Someone had to invent a compiler. Someone had to mine the silicon, make the chip, press it, assemble it in a factory, put it together, attach the QWERTY keys on the keyboard, ship it to my house. Someone also had to design the protocols that are used in this, or that are used for this laptop to connect to the internet, like HTTP or TCP or SSL. All of those things together combine to make this laptop what it is to me, or was. Those tools provide an interface that is simple, it is easy enough to use, it is a good abstraction that lets me work through the laptop without thinking about it. A useful tool provides a good enough interface that you can forget about the tool itself. And throughout human history, we are tool builders. We have always been building tools. Whether you think the first tool might have been a hammer or a bow and arrow, all the way up to today, the invention of the wheel, the invention of everything. Humans build tools. There was a great article I read on aeon.co in 2018 that hypothesizes that what is truly unique about humans among all animals and primates is that we don't just find tools and use them, but we create new tools to capture and store human knowledge and energy. And then we teach other people how to use that tool so those people become more efficient. And these tools are thus a storehouse of both knowledge and energy that can be passed on between generations. This is what has allowed humans to build on previous generations of humans. I believe the greatest impact of open source, the reason why it is so rapidly accelerated human progress, is at its core, we're building tools with computers and we're sharing them, and then the entire world benefits. Whether you have 2 downloads or 200 million downloads of your project, you've empowered someone else, so they didn't have to write that themselves. So the collection of all open source software, one might say, it is a grand library of tools for a knowledge-based society. But when you're building tools that the entire planet might use, this comes with some responsibility. Because technology is not neutral. Technology replicates the bias of those who built it. It benefits the privileged when the privileged build tools that serve themselves. You might have heard, there have been certainly plenty of stories in the news about machine learning and artificial intelligence being biased, not recognizing the faces of Black people as well as white people, or recreating and reifying the police patrol routes. The story there is that past criminal records were put in to train the system to predict where to go police. So of course the police are then looking in the same neighborhoods where they found crime before. That's incredibly biased. There are so many more examples of this that I am not going to go into, but if you're interested in it, please do look it up. There's a lot of really good work in this space. Technology is not neutral, and it is not apolitical, and every one of us who works in open source, we owe it to ourselves, to each other, to society, to understand the second-order impact of what we build. And that is not just the direct consequence, I built this tool, it did this thing, someone else downloaded it. Or I built this product, I run this service, and people use it. But to understand the consequences of those consequences. What will someone else do with the tool? What becomes easier for them to do? Are users at risk? Are certain demographics, certain minorities, more at risk when they use this tool than other people? We owe it to each other to consider those impacts. And there are some great new approaches to this that are under development and under discussion just in the past few years. One is called abusability testing. And that is the approach to not just design a good user experience, but to consider who that user experience will impact differently. Will minorities experience it differently than a majority member of whatever demographic is using your software or your platform? Can the tool be used to cause harm? Are there ways you can design the interface to minimize its potential to be abused? And the other principle is designing from the margins. Instead of focusing first on those customers who might be the majority of the market share, start from the folks who are the minority of the market and consider the impact on them. This means prioritizing accessibility features, prioritizing safety for women, for queer people, particularly in countries where being gay is still illegal. To prioritize, if your app is going to be used in those markets, consider how to build in safety for those people. As humans who have the power to build platforms and tools and open source for everybody, we owe it to each other to consider the harm that can be caused on those with less privilege than ourselves. And in today's political climate, with all of the news around cybersecurity and attacks, I think everyone today is thinking about software security and national security. We have the war on the eastern side of Europe, the Russian invasion these days. The pandemic has certainly disrupted a lot. And there's been a global shift from a culture of collaboration globally between countries to a growing culture of isolationism increase in nationalism in many countries, closing of borders, and we're seeing this also affect open source communities. In the US, there's a strongly renewed focus on national security and the security of our supply chains. And while some days it does feel like the wheels are falling off of the global shipping and global food supply chains, and the supply of computer parts is kind of dwindling and prices are going up, I'm not here to talk about those supply chains. But in 2021, President Biden signed Executive Order 14028 that compelled several federal agencies to begin focusing on software supply chain security, and in particular, the security of open source supply chains. This led the NTIA and CISA to partner with or to do outreach to a lot of private companies. It's led to a lot of renewed interest in the Open Source Security Foundation, where I am currently an advisor on the Technical Advisory Committee. And it's led to, for example, the publication of new procurement guidelines for the US government and the minimum elements of an SBOM. Those have been defined. I'll talk about those a little later in the talk. But first, I should start by talking about what is a software supply chain in open source, and do we owe this to each other? Is it important? That supply chain, just like in the example of the car keys or the laptop and the fabrication of all the parts of it, this is also true of our software. When I compile something or I build a Docker image, let's pick the Docker image example. If I just run docker build, it's pulling in components that other people have built. Those in turn, maybe there's a Debian package and then I add a couple things from PyPy. Those were built by other people. Those depended on other tools, and those on other tools. And the depth of these dependency chains, in many cases, is quite high. 5, 10, maybe 20 layers deep. Many of them haven't been traced all the way back before. And since open source is very pervasive today, it is used in everything from our computers and cell phones to fitness watches to smart fridges and cars and airplanes, power grid. The security of all of those devices depends on the security of every component in those open source supply chains. Some small logging library in the Java ecosystem could turn out to be very important to the security of the power grid or a hospital, for example. So this shift in 2021 led me to refocus my work. I've been working in open source as a contributor, sometimes as a project lead, since the late aughts, I guess about 15 years now. But only 1 year ago, I refocused really to look at software supply chains. And I started by just doing a survey of every community that I knew and could find out about, and go look and learn and see what other people are doing, and put it all together in a document and began to try and map out the domain. Understand what's out there before forming any opinions of my own. And the closer I looked, the more I realized it's a very tangled mess, and nobody understood the whole picture at that time. This is about a year ago. I couldn't find anyone who could draw me a diagram and explain how it all fit together, what all the pieces do, what are the essential parts if I wanted to build a product that could do this, or help advise a software product how to do it. 2 years ago, there wasn't a really good answer anywhere I could find in the open source communities. Now, people had solved it in a narrow scope. Pick one particular language ecosystem, or pick one particular problem like software signing, or checksums, or source code control, and there were solutions there, but overall, it seemed like an unbounded problem space. And so I stepped back after I finished that survey and asked myself, how can this be simplified? What question is at the core driving all of this? And it is a fundamental question we all as humans want to know: am I safe? This is at the heart of software supply chain security. Whether you are an operator at a power company or a cloud company, or you're writing a fitness tracking app, or you're just using a smartwatch, you want to know if you're safe, if your data is safe, if the technology is going to do something, to harm you, or if someone else can use it to do something to harm you. And there are national security implications, unfortunately, at every step up that chain. And the problem, it's a deep one. Turning the question from the general, am I safe, to the specific, can I trust this thing? Can I trust this piece of technology, this laptop, this phone? Can I trust this USB stick that I found on the side of the road? Can I trust this USB port in an airport to plug in my phone and charge? Can I trust the free Wi-Fi at a coffee shop? The answer to all of these is no, probably not. You shouldn't. You should at least take some precautions. If you're going to plug in your phone to charge, you can actually buy a little USB data contact terminator that, your standard USB plugs have 4 channels in them, and it terminates the 2 for data and only lets the power through. So that protects your phone from potentially being exposed to malware in a USB device that you plug into. If you're using the free Wi-Fi at a coffee shop, I hope you're also using a VPN. And when you're downloading software from the internet, I hope you're evaluating its trustworthiness. I'll get into that in a bit. I'm going to go back to being philosophical for a moment, because I've talked about safety and trust and security, but the question of what is trust is actually a very important one here. And it's not merely philosophical, but computer scientists have been asking this question for as long as we've had computers. Going back about 30 some years, Ken Thompson gave a great and very famous lecture after receiving the Turing Award. And the lecture was titled Trusting Trust. The question at the time was, can you have a trustworthy program? How do you know if it's trustworthy? If you've read the source code, is that sufficient? And his point was no. Even if you read all the source code, even if you wrote the source code just for that program yourself, the compiler could still inject some maliciousness into the program that it built. So the only way you could trust it, truly, is if you wrote everything all the way down. You wrote the software, you wrote the compiler, you wrote the linker, you wrote all the dependencies. And even today, you would have to also say that you wrote the firmware for the computer it runs on. All of that, you would need to do that to be sure there was no Trojan horse or no backdoor in it. So ultimately what it comes down to is trusting the people who wrote it. And that was Ken Thompson's point in summary. About 10 years later or so, the US government had issued a set of guidelines for procuring what they called trusted hardware or trustworthy hardware. And Dorothy Denning refuted this, saying that trust is not a property of the observed. Trust is a declaration made by the observer. That it's illogical to say some computer system is ultimately trustworthy, but rather that someone has evaluated it. And so if you're going to trust that to trust that computer that you didn't build, you need to trust someone else's evaluation of it. Fairly recently, about 2015, 2017, the Trusted Computing Group, an international standards body that works on trusted computing, their definition was published as trust is the expectation that a given piece of software or hardware behaves in a specific way. And I like that because it puts the responsibility on the person who is ascribing trust to say what they expect it to do. And then last year in 2021, a colleague of mine, Mike Purcell, wrote a book, and it goes much, much deeper into this topic. It's titled Trust in Computer Systems in the Cloud. And in that book, he postulates 3 corollaries of trust, that trust is always asymmetrical, contextual, and time-dependent. So, what is trust in the context of open source? When open source licenses come with no warranty, no guarantee of fitness for any purpose, how can you trust it? Well, it's free, right? And we like to say that open source software and free software is free as in pizza, free as in beer, because it's just like, well, here it is, take it if you like it. I also like to say that it's free as in puppies. Once you've adopted the open source software and you're using it in your organization, you've taken it home, you've got to maintain it. You've got to, feed it, take it out for walks, patch a bug, update it. So it's not really free in the sense of free forever, but it's free as in free for now and free like a puppy. The roots of open source go back further than the actual term open source. They go back to the free software movement. And one of the other phrases people like there is to say it's free as in freedom. And the 4 freedoms of free software are to run it however you want to study it, to change it, and to redistribute it. So those 4 freedoms are granted without any warranty. I dare say that alone is not enough to instill trustworthiness in software or to make me trust it just because it's free. But these 4 freedoms are crucial to how we build software at scale globally today in this modern knowledge-based society where we're all building tools and giving them away. And the corollary to the 4 freedoms, I believe, is the 4 opens. That the software is open source, that it follows an open design process. What's happening next, the next features, the architecture, that's all open. It follows an open development model where everyone can participate and there are checks and balances in place on that participation to ensure an even footing for everybody. And an open community where the governance structure, the code of conduct, those are all documented publicly, and the community is welcoming of a diverse group. Everyone can contribute. These 8 areas are essential to today's knowledge culture. The 4 freedoms protect what we can do with the software, and the 4 opens describe how to build software together, collaboratively and safely. The 4 opens create the confidence that free software can be trusted, and they are commonly used at the largest open source projects in the world, from the Linux kernel to OpenStack to Kubernetes, and so many more. They rely on the same principles that are described here, the 4 opens and the 4 freedoms, even if they don't call them those anymore. And the OpenSSF, even in defining the software levels of assurance, the SALSA framework, is in many ways describing the 4 opens in the same process as well. But when we look at the landscape of open source, everything today, there is a distribution curve. There are a very large number of contributors engaged in a very small number of projects, and a very large number of projects, the majority of them, with a very small number of contributors per project. To implement the 4 opens in a software development community, you need checks and balances. You need a robust CI system with a gated commit. You need multiple reviewers, and that's just not tenable for many small projects. They lack the capacity. So what do we do about the long tail? Those thousands of packages like Log4j that only have a few maintainers, people just working part-time, and the world relies on them too. If the next bug happens in another one of those projects at that right side of this graph, number 2, what do we do about the next one, and how do we build systems to prevent that? Many proposals have been put forward in the last year and a half, and there's many more that are still being discussed in places like the OpenSSF and the CNCF and OWASP and chaos and in the halls of nations. But many of the proposals out there lean back on security and isolationism and the principle that principles that might apply in a different setting than an open source community, principles that might apply inside of a government or inside of a company or inside of a military, but those don't work in a global, open, equitable, participatory community. In our desire to make open source software safer and more trustworthy, we must not impinge on those freedoms, and we need to consider the second-order impact of anything we are changing at the foundations of how we build open source software. We owe that to each other, to be socially responsible. When we seek to improve one thing, I have to ask, who else will be affected by this? And is that trade-off acceptable? Now, if I restrict access to my house to just my friends, I'm only protecting my safety, not affecting the world or others. If I restrict access to tools that I build, that is not open source. There might be some valid reasons to do that. But if I restrict access to participate in open source, I am restricting access to participate in a knowledge society. And that is a systemic injustice. We must work against that. We need to work to protect the diversity we have and increase it, to ensure that everyone is welcome to engage and collaborate and contribute in open source. This takes hard work. I was part of the Kubernetes Code of Conduct Committee for quite a while and helped to shape that as it grew for the past couple of years. And yeah, I tell you, running a code of conduct process, it's a lot of emotional work, right? Just having a document isn't enough. That was a loud bang. Sorry. If you have a public-facing community like most open source is, you might rely on moderation tools. I have seen some people suggesting that we rely on ID checks and government issue ID to allow entry, to allow contributions to open source, and that's not going to work. That works against diversity. There's lots of people who, for a number of reasons, don't want to and can't use their legal name in the public. Consent is another radical idea these days, or at least it often seems to be. Data autonomy, consent of how my data gets used, really hasn't existed, and it's only getting worse with the ad industry sort of sweeping all the data up, the pervasiveness of technology, selling our data to others. I am hopeful that the US might eventually adopt GDPR-like regulations around data privacy and data consent. Not the little consent pop-ups you see on websites. That's not actually consent. Because if you need to access a website and it forces you to accept some terms just to access it, that is compelled. A compelled agreement that is not true consent. You don't have a choice to say no. And bodily autonomy, consent over what happens to oneself, that is also under threat in America, specifically for women and trans people, and also in other parts of the world. So these days, these concepts of diversity and consent are even more important because they're getting pushed back. And in privacy, it's a foundational right in any civil and democratic society, and it is also at risk. From calls to poke a hole in Section 230 or just remove it completely, calls to enforce broader moderation on social media platforms under the guise of fighting CSAM. Those requirements would actually harm all of our privacy. You might have seen the news where Apple tried to scan everyone's image on their phone. That was about a year ago, I think. Right now, in May of 2022, the European Commission is considering something even more extreme, requiring that all messages sent, whether it's a text messaging app or an email or anything, that all messages be scanned in the same kind of way that Apple was going to do. And this is a terrible invasion of privacy we must push back on. Without a right to privacy, we will lose so much. In America, there are a number of court cases that used the right to privacy as the basis to establish other rights, such as the right to contraception, the right to gay marriage. We lose this right, we lose a whole lot more. So when you're building software or open source projects, consider how that project affects all of our rights to privacy and our expectation of it. Can that project be used to, do data mining on individuals or combine data in ways that might make someone uncomfortable if they knew the data was being combined that way? I think the ad industry at large is based on invasions of privacy. It doesn't have to be. It wasn't always that way, but it has become increasingly so over the past 15 years. Without privacy, all of our other freedoms are imperiled, including our freedom to work in open source. And lastly, one that I don't think gets talked about very often, pseudonymity. Many of the older open source communities had this from day one. The old culture on BBSs and IRC and games in the 90s and early 2000s, everyone used an alias. You did not, and you still do not, need to know someone's legal identity to develop trust in them over time. They can have a reputation. To see that their code is good, multiple people could review it. We can create mutual accountability without knowing a legal identity. And this is a core right also to free speech. In open source, this looks like having good checks and balances in our projects. Two-party commit process with gating, for example, gated commits. This has kind of been a standard process in a lot of open source projects for decades, and today it is in jeopardy. As Ken Thompson pointed out almost 40 years ago, merely knowing who wrote the software isn't enough to guarantee the software is trustworthy. So I want to ask, do you think open source software can be truly open and also safe? I do. By trusting the process. And I've mentioned a couple times the 4 opens and this process of mutual accountability in software creation. This was pioneered by the Drizzle project, or by a group of people who happened to build Drizzle in about 2008. Perhaps the most influential and smallest open source project you've probably never heard of. That is where the sort of groundbreaking work on two-party reviews with a gated CI system. Code was only merged by a computer. It was never merged by a person. This was pioneered there, and that precedent was then established and used in OpenStack, carried forward into Kubernetes and the Cloud Native Computing Foundation, and now so many other communities, even GitHub workflows, support this as well. OpenStack and Debian before it also had a vulnerability management team and process that was documented, transparent, and open, that included handling embargoed vulnerabilities. That is, when someone discloses a vulnerability privately and then develops a fix privately, they had a process to notify downstream stakeholders of those vulnerabilities under embargo to do a coordinated fix before release. As far as I'm aware, Linux kernel, Debian, and OpenStack were the 3 community organizations to do this first. I'm not counting Red Hat, as that was a company much longer before this. But that is now part of standard guidelines for a large open source project. But all of these approaches, while they may work for large projects like Kubernetes or the kernel, they don't work for small projects. They're too heavyweight. So if we can't trust, if we can only trust software that we haven't built ourselves because the process is trustworthy, and yet a large number of open source projects, most of them, aren't large enough to have the process that I've just described that makes them trustworthy, makes the big ones trustworthy. What can we do? Can we trust something else when there are too many people developing important open source projects for us to know all of them personally? Is there something we can replace blind trust with something else? We are tool builders, after all. Humans are great at that. And so many people are trying to build new tools today to solve this problem. Trying to build tools to generate SBOMs and signatures and whole new approaches using blockchains to do all of this. But with every new tool comes a new cost, whether that cost is the cost to run that tool in your CI system or the cost to just learn how to use it. If you're a volunteer in your spare time maintaining some critical small logging project, you might not have the time to learn this new tool. So there's a few I'm going to mention in particular. Software signatures, right? Today, most software packages are not signed, and it would be better if they were. If everything were signed, it wouldn't solve all of our problems, but it would close certain gaps in the software supply chain. Tampering in transit or tampering with the package while it is in at rest in a software repository. But much like Let's Encrypt enabled OpenSSL and SSL to be everywhere, it didn't mean that all websites were trustworthy. Malicious websites could also use SSL very easily as a result of Let's Encrypt, its wide adoption. So as projects adopt tooling to automatically generate signatures for all their packages and everything gets signed, I think that'll happen over the next few years. Keep in mind, though, that just because a package is signed doesn't mean it's trustworthy. You also need to go evaluate that signature to determine if you trust it. A signature, remember, is just someone else's statement that they trusted the software. But who are they, and why should you believe that? There's a bunch of work happening around multiple people signing the same thing or creating immutable assertions of trust in something. That's all good. It's all trying to solve this in different ways. But ultimately, you shouldn't trust it just because it's signed. That helps a little bit. SBOMs will help a lot. This is software truth in labeling. Think about it like when you buy something in a grocery store. The list of ingredients is, tells you what's in it. It certainly helps you detect if there's any allergens in there. But it doesn't tell you enough about where it was made. There's often also a little serial number or a little stamp that can tell the factory or the store or the government the entire supply chain behind it. So SBOMs today don't do that. They just give you a little bit of information about what's in the container, what's in the package. And as the SPDX specification and other specification formats and tools evolve to generate SBOMs, I think these will also become very widespread, hopefully automatic in most software, automatically created for most software, But they will still not have enough information. SBOMs will not have the depth to go all the way back to the source code of a given project, of all the dependencies of that project. At least not in their current design. Maybe the SBOM formats will evolve that way. But generating SBOMs does still take work. And I've been looking for a zero-effort solution. And about 6 months ago, with one of my colleagues at Cisco, we launched the GitBOM project. This is a minimalist approach to automatically creating a complete artifact dependency graph that should work across languages, both compiled and non-compiled, across packaging formats, across ecosystems and operating systems, in a way that is completely transparent and also requires zero developer effort along the way. Instead of building a new tool and then trying to convince every open source project to use that tool to build an SBOM and sign it, both admirable efforts, but not what we're doing here, Gitbom focuses on the bounded space of open source build tools, compilers, linkers, packaging utilities. Those projects, by and large, already have a lot of contributors, a healthy community. And by adding a relatively small change in a consistent way to that bounded set of build tools, this will enable instrumentation from the earliest source code file, .c or .h file, when you build a shared library and that gets linked into a dynamically compiled language, that gets eventually turned into a Docker image, all the way through all those steps. Once the build tools support this format, it would at the end have a fingerprint that lets you see and visualize the full graph of dependencies all the way back to the beginning. Now, it's still early days for the Gitbom project. If you'd like to help, we'd love to have your help. The community meets every week. There's a Slack channel. All the info is up there, gitbom.dev, or just scan this QR code. Thanks so much for coming to my talk on trust and how we build it in open source.